Hello, this is Mr. Adamson. Today we're going to talk about how to convert improper fractions into mixed numbers. We'll start quite naturally with problem number one. In problem one on your sheet, you'll see that this is the improper fraction of 13 thirds. We call it improper because there's more stuff up top than we have groups in the bottom. So we're able to make more than one group here of these thirds. One way to think about this is I have 13 things, and these things are thirds. So I put them together in groups of 3 because they are thirds right here. So I have 13 things. Well, here's how many groups do I have? I have 4 full groups. I'm able to make 4 full wholes. So I have 4 complete groups. But I got this one extra guy hanging out right here. So I do have one extra thing. And what are these things? Well, they're thirds because it takes 3 of them to make a group. So we call them thirds. So this one extra thing is an extra third. All right, and problem number 2 here is 29 fourths. Now, I don't want to have to draw 29 things. That would take me forever. So what I want to do is just think of this rather as a division problem. Every fraction you have ever seen or ever will see is a division problem. This is another way to write division. This is the problem of 29 divided by 4. I'm trying to think how many groups of 4 exist in 29. Now, it won't go in there evenly, but I am able to get pretty close. So I got to think, all right, 4 groups of what get me close to 29? Well, 4 groups of 7. I'm able to get 7 full groups of 4 in 28, but I do have one extra thing. I have one extra piece that doesn't have any partners. One extra what? Well, one extra fourth. All right, moving on to problem. So in problem number 3, we have 9 halves. And in this case, it's pretty easy to think about. All right, how many times does 2 rather fit into 9? Well, 2 goes into 9 4 times, because 4 times 2 would be 8. And I would have a remainder, a single remainder of one extra piece. But in this case, these pieces are halves. So it's 4 and 1 half. Moving on to problem number 4. We have 5 halves, so just like the one before, just have to divide by 2. Well, what is 5 divided by 2? 2 goes into 5 2 complete times. 2 times 2 would be 4, and I would have one extra piece. What are these pieces? Well, they happen to be halves. Now, up to this point, everything we've had has been a remainder of 1. Is that always the case? No. For example, here, that will not be the case. So I just think, all right, 27 divided by 4. Go through my 4s. Well, 4 times 6 would be 24. So I am able to get 6 complete groups of 4 out of 27. So there's my big fat whole number. I'm able to get 6 groups of 4 with 27 things, but I will have a remainder that's not 1. I'll have a remainder actually of, well, 27 minus 24. Means I got 3 extra things. What are these things? These things happen to be fourths. And finally, our last example problem will be 52 eighths. And we have to think, oh, how many times will 8 go into 52? Well, 8 times, let's see, 8 times 6 would be 48. And 8 times 7 would be 56. Do I have 56 things? No, I only have 52. So I can't actually make 7 full groups, but I am able to make 6 complete groups. So 8 fits into 52 6 complete times, and I will have a remainder. So I took care of 48 things, but I had 52. So if I had 52 groups and I removed 48, I would have 4 left. 4 what's? 4 eighths. All right, the rest of the sheet is for you to finish today. Don't worry about the back. We'll take care of that tomorrow.